Alan said, my creative component I did over the survey of leaf rust and powdery mildew in the southern Great Plains. A little background about myself is I grew up on a winter wheat farm in north central Oklahoma. Been in agriculture all my life. Grew up driving tractors on the family farm, cut wheat, and so small grain has fit in my life the whole since I've been little. Went to college at Northwestern Oklahoma State University in Alva, Oklahoma. Got my BS in agronomy there. After graduation, I went in to some different internships and then went into the co-op management side on the agronomy side of the co-op system. Then recently, 3 years ago, I made a move into a wheat research company, and that company is Lima Grain Cereal Seeds, which is a French-owned wheat research company. And our headquarters out of Fort Collins, Colorado, but I work out of the Wichita, Kansas station site. And we cover, I help manage or help the plant breeder manage trials all the way from South Texas on down up into Canada. So we cover quite a geographic area. I've been married happily for 7 years to my wife. We have a 3-year-old boy, as you can see in the picture, and are expecting a little girl in mid-June. And I'm going to introduce you to the diseases that I've been talking about. The first one, which is the most common rust disease in winter wheat, and that's leaf rust. Some of the environmental factors, development-wise, temperatures from 59 to 72 degrees Fahrenheit, and humidity around 100%. The life cycle of leaf rust starts down south, usually in Mexico or South Texas, where there's green plants, basically year-round. It overwinters down there. In the spring, the spores open and spread by south wind, moving its way north into Texas, Oklahoma, Kansas, and a little bit in Nebraska. Usually stops there because of the colder winters. It can't survive the colder temperatures. So not Kansas, Nebraska, about as far as north it goes. So in the springtime, the spores reinfect the green tissue from moving all the way north. Like I said, the most critical thing for leaf rust is the south winds carry it north. And by that time, the white ripening wheat is greener in those areas, so it keeps on moving its way north. There are 8 major areas in the U.S. that can get leaf rust. One is mainly the southern adapted wheats, which is the southeast part of the U.S. The second areas 2 and 3 is the northeast, which is mainly soft reds and soft whites. And then you get 4, 5, and 6, which is the Great Plains. They have a mixture of mainly hard red winters, and then there is some Durhams up north, and there's some springs up in the Dakotas and Montana and Wyoming. And leaf rust can affect those. And then area 7 is the southeast part of the U.S., which the spring wheats are planted in the fall. They have a longer growing season, a better growing season. The temperatures are higher, so you can grow wheat basically year-round there. Then 8. The 8th area is what commonly called the P&W, and the soft whites, and there's even some hard reds being planted up there now. So it's transitioning into the areas, into different areas of the U.S. that might not have seen it before, like number 8, the area at the P&W mainly gets stripe rust, but they're starting to see some leaf rust moving into that area up there. There's just another map of outlining where the major wheat areas are in the U.S. As you can see, in the Great Plains are the major acres and the major genes that are found of leaf rust in those areas. There's not many leaf rust genes in the southeast part of the U.S. because there's not much wheat grown there acreage-wise. So in the same way for the northeast part, but there still is leaf rust genes found up in that area. In the P&W, there's very little leaf rust starting there, but the stripe rust is the main disease up there. And these are some leaf rust genes that are commonly found in some of the varieties that are commonly planted in the Great Plains or in other areas. LR17, LR39, and 41 are commonly found in lines Jagger, M111, and Post-Rock and Fuller. Those are all hardwood winter wheats, grown mainly from Texas up into Kansas and a little in Nebraska. The second phenotype is LR11, 26, and 18. And these are found mainly in the soft reds, which would be in the eastern part of the U.S., where it's a little bit more humid and the temperature is a little bit cooler. And the third and fourth common phenotype is LR24, and it's found in Jaggling, Cutter Hike, Hitch, and Overall. The regional differences is because different leaf rust strains are in different parts of the U.S., so you have to plant the different varieties, but you have a good selection there. So if you're selecting a variety, you can select by the leaf rust genes that are in the variety for your certain area. Powdery mildew is the second disease that I looked at in my creative component. It's probably the most common in the cereal seeds or any other crop. It's a fungus, and it likes 59 to 72 degrees Fahrenheit too. And it's mainly found in high densely populated wheat fields or any cereal seeds. And it likes the cool, wet environments with humidity too. This is the disease cycle of powdery mildew. It is not spread by south wind like leaf rust is. It develops from wetness and moisture on the bottom leaf, starts from the bottom leaves and moves away north or up the plant and reinfecting the green tissue as it goes up the plant, or it can affect neighboring plants if the leaves are close to the infected plant. My creative component, the objectives for this was to examine the leaf rust and powdery races found in the southern Great Plains. And this will help the plant breeders, wheat breeders especially, in the Great Plains, figure out which leaf rust genes are out there and how to control and which ones to select for, which ones that are still working and not broken. I had 2 trial sites, Wichita, Kansas, which is where I work at, the Lima Grading Station. Then I had another site in Waukegan, Oklahoma, which is our family farm. We had trial sites there. We just tagged them on to our trial sites. And we picked these 2 locations because Oklahoma is the second highest planted acres of wheat in the nation, and Kansas is #1. And we just thought it made a better fit than anywhere else. The Oklahoma site soils is a Kirkland silt loam with 1 to 3% slope. The previous crop was a winter wheat crop, continuous, and we disked it and chiseled it throughout the season, and we applied 70 pounds of actual N for the top dress in springtime. At the Wichita, Kansas site is a silty clay loam soil and fine sandy loam with very little slope. And at the station, we used a wheat fallow rotation system to break up the disease cycle there on station. And we disked and chiseled for the tillage, and we applied 60 pounds of actual N for the top dress in the springtime. The drill we used was a Winter Steiger row seed XXL head row planter. The planter can plant either plots or it can plant head rows. Our plots are typically 10 feet long, 5 feet wide. Our head rows are 3 feet long and roughly 4 varieties wide. And that's what my credit component lines were planted, were head rows. I used 88 winter lines that had different leaf rust genes in them and powdery resistant genes in them too. Each site was 2 replicated tests. The first rep was in entry order. The second rep was randomized. And the germplasm came from WGRC in Manhattan, Kansas, which is kind of like a storage bank that holds different wheat lines with different leaf rust or powdery mildew or different genetics that are out there in winter wheat. They handle it and hold it for you. Throughout the season, I collected data three times using this scale, a 0 through 9 scale system. 0% was basically the leaves had no infestation of leaf rust or powdery mildew on them. it's 90% of the leaf was covered with leaf rust or powdery mildew. And this is the most common data collecting system in a disease rating area. This is the disease cycle. To have a true disease, you have to have the host, the right environment, and the right pathogen at the right time. If you have all three of those, you have a true disease. And for winter wheat, you have to have a susceptible line to the disease. You have to have the right environment to grow the disease, which in this case is leaf rust or powdery mildew. Then you have to have the right pathogen that can mutate and grow into the disease. And for leaf rust, the host is susceptible winter wheat variety. The environment is high humidity and a strong south wind, and the pathogen is leaf rust. And the south wind is the most crucial point into a leaf rust outbreak in the Great Plains. And since the wind from the south starts in Texas and works its way north, and so does the plains right here. The weather data for Medford, Oklahoma, and Medford's about 15 miles away from Waukeeta, was the closest weather station to Waukeeta. In 2012 was the ideal year for a leaf rust outbreak. As you can see, the temperature, which is in this column here, was mainly in the 80s and 90s, and the nighttime temperature was in the 60s. And you can tell the humidity was in the upper 90s and the 90s, and the wind was mainly out of the south, and a gentle breeze for us. 15 mile an hour will help spread the disease out through the Great Plains. And there was an early infection year at both sites in 2012 because we were so warm and the humidities were so high throughout the growing season. It was a different story in 2013 at Medford. The maximum temperature only got to 90 one day out of the whole entire month, and the nighttime temperatures we got to 60s and a few 70s. So you get those two to combine is not conducive to a leaf rust growing season, even though our humidities were up there. Plus the nighttime temperatures that were low and the daytime temperatures were in the 70s, so we did not get a true leaf rust disease outbreak in Medford, but it was sort of Waukeeta. But that's more of a kind of normal year for leaf rust, and the south wind was not there until later this season. Now, Wichita in 2012, the high temperature was mainly in the 80s and 90s. Low temperature were in the 60s. Humidity was a little low in the 70s, was not quite in the hundreds or the 90s. The wind was mainly out of the south, and the direction, and the wind speed was not gusting to move the disease further north. But in Wichita in 2012 was a normal year, and this came in earlier. The leaf rust came in earlier, and it set on the plant, and we actually saw some leaf rust strains or genotypes break down because it set on the plant so long that they mutated into a different gene, basically, changed its appearance. And like I said, like Medford in 2013, the Wichita was completely different too. We were a lot cooler. Temperatures were in the 80s and 90s, very little until the end of the month. Then we started getting in the 80s, and the temperatures started getting up. And the humidity started to get up, and the south wind started getting up. And in Wichita, there was leaf rust at the very tail end of the season, which really did not affect the wheat plant too much because we were already starting to ripening down. The green tissue was starting to go down. So it was there, just not too prevalent. This is a table that represents just a small portion of the main research, and the entire data set can be found on figure 14 of the graded component. Jaggeline, the one that is highlighted, is a very susceptible line to leaf rust and powdery mildew. We commonly have a running joke with Jaggeline in the Great Plains. If you sneeze on it or cough on it, it'll catch the common cold. So it's a very susceptible line to any disease out there. And as you can see, in the year 2012 and 13, in both sites, 2013 was a leaf rust, and back to its normal year, and we had a leaf rust rating both mid-season and late season. Here is some lines that show some resistance. The ones in green, highlighted in green, show very good resistance in Kansas in 2012, which had very little showing any disease rating on the leaves. You see a semicolon off to the side. That's what's commonly considered flecking. That means the plant did get leaf rust on it, but the plant is fighting it, like they commonly call it. It has the virus, the right leaf drying gene in it to fight off the rust spore in it. And the ones highlighted in green also too, as you can see in Oklahoma, we're showing some difference because we had a leaf rust infestation in 2012 and 13. But in Kansas we didn't have anything. So we're seeing some difference between the leaf rust types and strains within the two different states. So we are seeing some difference of the leaf rust strains already. And then the ones in green, or the ones in blue, showed very good resistance in Kansas, 2012 both and in Kansas and Oklahoma. But 2013, they showed a lot of susceptibility on the 2013 side in Oklahoma. The ones in the blue, like I said, still have the semicolon, so they're fighting it. And in Oklahoma, they have very low ratings. And a low rating, you can still pass those on for approval. Just you can't have a clean plant where you don't want a clean plant. So you may have a low rating. It may yield good, it still may make good. It has other qualities that may help out. This slide shows a few lines: KS 96 WGRC 39, KS 91 WGRC 11. Showed some, as you can see in the mid-season, it had a moderate rating, but as the season went on, the rating went up. So what that tells us is mid-season, the plant may have been trying to fight off the leaf rust gene, or the race, that it just succumbed to in the later part of the season. So the leaf rust gene might have been breaking down, or it might have been just too much on the plant that the leaf rust overtook the leaf, basically. And the ones highlighted in green or blue had a higher leaf rust rating in mid-season and lower at the end of the season. This is also due to the plant may be able to take a lot more leaf rust in mid-season, and as the plant matures, maybe get better at fighting off that certain leaf rust strain in the later season. And that shows you in Kansas, it shows you that, but in Oklahoma, it's just kind of backwards, it went up. So those leaf rust genes that show that in Kansas may not be the same ones in Oklahoma, or they may be showing different growing conditions in both sides, in both places. And this slide shows basically in 2012 the disease cycle of the leaf rust infestation was a high rate, no matter if it was mid-season or late season. It pretty much stayed the same compared to the other slide that shows some difference in the leaf rust strains out there showing. And jangling, like I said, it has there to check because it's the most susceptible and easiest one to rate on. I'm going to talk a little bit about the growing seasons and how they were different. In the 2013 growing season was cooler at first, but later in the season, when the plants started maturing, we did start getting warmer, and we did start seeing leaf rust move into the area, especially into Kansas. Whereas the Oklahoma side had leaf rust throughout the growing season because they were warmer and the humidity was there. And the 2012 growing season was a hot, humid year at both locations. The leaf rust was there earlier in Kansas and stayed there and changed some of its form. Some of the leaf race strains started breaking down. And so the varieties that had that gene started breaking down and getting infected. And on both seasons, leaf rust was present. It's just a matter of how severe. The disease that we did not have, because we did not have the right conditions, was powdery mildew. Powdery mildew in the Great Plains, right behind leaf rust, is probably one of the most yield-robbing diseases out there in the winter wheats. The center square shows you a healthy disease triangle. You have to have the environment, the pathogen, and a host. With powdery mildew, in both years, the environment was missing. The powdery mildew was there, just not enough to warrant a spraying or treating or enough to take a rating on. And the host was definitely there because we had plenty of acres of winter wheat grown in those areas. The wind was not out of the wind was mainly not out of the south. It was kind of out of the north and east. It kind of varied, but not enough. We were drier. We were still in the middle of the drought in the powdery mildew season. So that's why you won't see very much powdery mildew from my creative component, because we're missing one part of the disease triangle. And in conclusion, the creative component was done over a 2-year time span to observe the leaf rust strains and the powdery mildew strains in the southern Great Plains. This is very important to the wheat breeders in the southern Great Plains, because they want to know what leaf rust strains are out there, so they can do a better job of breeding the newer lines with certain leaf rust genes in them. And now with this, since we saw an onset of changing leaf rust in 2012, if you have a line that can last or survive the 2012 season and the 2013 season, you want that line picked, because you saw a change in 2012 compared to 2013 or any of the previous years. The biggest factor in my creative component was the weather. If you don't have a south wind or strong south wind, high humidities, high temperatures night and day, leaf rust won't be there. Or it might come in later when the plant's already starting to mature and die off, and you may not have enough infection to get a good reading of it. So the weather is the main factor in these two diseases. And answer any questions that you might have.
I just have some general questions. I'm not familiar with diseases in wheat at all. So what effect does the rust have on the plant? You said if the plant gets it later when it's already starting to mostly mature, the yield is still okay. So what does it do to the plant early on, and how does that affect yield?
Leaf rust is mainly we'll get on what we call the flag leaf. That's the main leaf of the wheat plant that grabs the sunlight and takes it into photosynthesis, and it helps head development, grain filling. So it's your main leaf.
Where's that leaf located on the plant?
About usually up on the upper tier of the plant.
It's the top leaf.
It's the top main leaf. So with the leaf rust, it can affect all the way from the bottom all the way to the top if it's really bad year, or it can affect the flag leaf and the one below it, and those are the two main leaves that will help the plant grow. So if you have an early festation come in, that leaf rust will set on there, it'll put stress on the plant, and it'll also slow the photosynthesis down, where it will kill the grain head, or your grains may be what we call birdseed, small, and doesn't amount to basically anything. And then powdery mildew is about the same way, but it can go from the top all the way up on the head, on the arms. It can about the same way